This time on Voice of the Sea, we're learning how invasive algae are being used to detect cesspool contamination across Hawaii. Scientists are analyzing the nitrogen levels in algae to see where, along our coastlines, the cesspools are leaking most. Cesspool contamination isn't just a human health hazard, it also damages corals, fishes, and even native Limu populations. We'll learn how scientists are gathering data and what can be done with technology and policy solutions to help improve the way we treat our wastewater in the future. We start off talking to algae expert, Dr. Celia Smith.
I've had the good fortune to be at the University of Hawaii in the botany department and now the School of Life Sciences for over 30 years. I was hired as a tropical marine ecologist in the botany department, so that meant that my initial agenda was going to be to understand the ecological processes that involve algae on our tropical reefs here. We've had studies that have looked at algal communities across several of our high Hawaiian islands. We've had studies that have looked at the mesophotic flora. With my students' great help and their innovations and interests and energy, we've made some significant contributions to understanding how reefs work here in Hawaii.
And when we start talking about cesspools and the potential influence of cesspool leakage into our environment, out into the ocean and our reefs, how does algae play a role in that?
Great question. It's important to realize that the plant community on a historical basis was present in these reefs even before corals occurred, before fish occurred. We are dealing with green and red algae as ancient evolutionary clades, very early in the evolution of eukaryotes. These photosynthetic macroalgae that we have now, their progenitors arose about 1.6 billion years ago. And so I like to think of our reefs as being algal dominated until about 200 million years ago when corals, reef building corals, finally evolved. And that, I think, is a key perspective because it tells me that, of course, algae are on reefs everywhere, all the time. And that is coupled with the fact that we now have grazers that depend on them. And so if the grazers are there and you don't see the plants, it's probably because the grazers have eaten them.
And by grazers, you mean like fish or invertebrates that eat algae?
Correct. Grazers could be reef fish, it could be urchins, it could be us, humans, as well with our love of Limu. My view of the coral reef is very different than a typical coral reef biologist view. Seeing that over 1 billion and 1.4 billion years, these plants have been evolving strategies to allow them to be successful, to allow them to be native and dominate in these ecosystems. And so, in a way, how is it that coral could push algae out of those reefs that they dominated before? And that is the essential link back to herbivory that the fish and the urchins provide to provide some regulation or balance between the occurrence of their food and allowing coral to become dominant. It's quite clear without herbivores, there would be few coral, right? They'd be overgrown because every alga can grow faster than a coral. It's an impossible race for corals to win and hold on to space unless there is a grazer that is more hungry than the plants can grow. Does that make sense?
It does, and then it makes me think about, like, we have this wonderful assemblage of different types of limu that grow in Hawaii, intertidally, as you mentioned, really down deep to mesophotic depths. But we also have a lot of introduced species that compete for that algal space.
That's right. And so the conversations that I've had with people make it clear that they love these ecosystems, they love these habitats, and they want to know why they have changed so profoundly. Where is the Limu kohu? Where is the Limu kala? Where's ele? Where's Limu palahalaha? Why aren't these species I used to collect, why aren't they here now? My lab's research has been highlighting over the last maybe decade is actually that those invasive species that came here by riding on a fuel barge from Guam, like Acanthophora, or intentionally introduced, like Hypnea muciformis, they got the foothold that they were able to carve out, in part because the native habitat dimensions had changed so profoundly in these modern periods from about 1950 on. And so how could those dimensions of a habitat change profoundly? One of them is that our reefs are chronically overfished. We just simply do not have the herbivores to regulate those plants, the native species. But secondly, from probably the 1900s to current, we are loading our ecosystems with nutrients that are shifting the competitive interactions, and the invasive species thrive under those altered conditions of high slugs of nutrient coming into our ecosystem. To me, it's actually kind of poetic that in the end, the plants that respond to those nutrients that are coming from wastewater through the ground and up into the coast are macroalgae, and they are largely invasive algae. And so we are putting the invasive algae to work for us now with the Act 125 funding that we have that allows us to go and collect them, process their tissues, and then analyze the tissues to get parameters that help us understand if the plume of pollution is actually reaching that area or not. You probably know that we have over 88,000 cesspools in the state of Hawaii. We are at the head of the line nationwide for their use, and that's pretty tragic in the terms of the consequence to the health of the reefs. These cesspool leakages are about 53 million gallons a day. We suspect that there are significant amounts of nutrients flowing into particular target areas. And we actually are collecting the algae in those areas. The invasive algae are our strong signal that we are seeing something that's impacted. Through the tissue analysis, we're actually able to see areas that are healthy, as well as areas that are receiving significant amounts of nutrients. For about 15 years, people in my lab have been collecting invasive algae, cleaning them, drying them, and grinding them into a fine powder. They then go over to the stable isotope lab for a very sophisticated set of tissue analyses. While these approaches may sound kind of fancy and maybe technical, they are being used worldwide. We're actually a little bit behind the game in terms of international scientists in New Zealand and the Mediterranean using these same approaches that we are now applying here in the Cesspool project, helping to understand the impact of the cesspool contamination. And this means that as we think about these probes, they're also pointing the way to the future. If we want to get rid of these invasive algae, cutting off the sources of this fertilizer input is the next step. And so these cesspools that are in coastal areas are leaching not just the fertilizers that are driving my plants, the invasive algae, to bloom, but they're also loading our coasts with pathogens that will lead to gastroenteritis, hepatitis A, cholera, conjunctivitis. We have to look to the future for a healthy set of reefs if we're going to survive what climate change is already doing to these ecosystems. If having fish for our meals when Costco and Walmart and Sam's Club can't deliver, if having fish on our reefs is important to us, then these cesspools need to be removed. Food security and having the ocean for our families to use in the future, gosh, if that can't get us motivated as a community, what can?
The University of Hawaii's Sea Grant College program focused on Hawaii's coasts and its communities through sustainable development, safe seafood supply, sustainable coastal tourism, hazard resilience, and healthy coastal ecosystems. Hawaii's Sea Grant.
Researchers are using Department of Health maps to predict where cesspool leakage is high and then collecting algae along sections of the nearshore environment that are cesspool affected to compare with areas of little cesspool contamination. Bree Ornalis explains how algae samples are collected, processed, and analyzed.
A water sample is a snapshot of what's going on in time in the water. So that's how the water was on that day at that time that you took the water sample. Algae, however, incorporate the water and their nutrients into their tissues, and they do this over a long period of time. And so the algae tell us a much larger story. Instead of one page, you get the whole book. We collect all over the island and across the entire state. I personally collected on Oahu and on Kauai. Our field tech team, we were all women, so we called ourselves the Cessy Sisters, like Cesspool Sisters. Because that's what we did every weekend. We were just getting in dirty cesspool water. The algae that we collect is typically Ova lactuca or Limu palahalaha. It's called the sea lettuce, or Acanthophora spicifera, which is an invasive species. Those have the most history with isotope analysis, so that's what we kind of like to use. And typically Acanthophora, which is an unfortunate fact, is that it's normally really readily available throughout the islands. We collect kind of like a palm-sized amount. That's kind of big, but like maybe a golf ball in your palm. And that goes into your 3 little baggies. You need a golf ball per bag, and that's sample 1. You take your GPS point, and if you're also doing water sampling, you normally have a YSI meter, so we kind of have different people in our teams. We do teams of 2 or 3, and anytime we had fresh water points where we had really low salinity drops, we would take a water sample in conjunction with the Limu, and we took that back to the lab as well. If we collect ova in one area but Acanthophora in another, because ecosystems do change as you go along, we try and do a calibration site. So we try and find a site that has ova and Acanthophora in it. And so we will collect 2 samples for that one particular area. And that way, when we process them and run them at the isotope lab, both will get averaged, and we can kind of compare those to each other.
Can you visually see differences in algal growth that might be caused by the cesspool leakage?
Yeah, absolutely. Some areas you can visually see that the water is murkier. You know what you're getting into. Other areas, it's not necessarily that you can see that there's leakage. You can see freshwater seeps, either from the sand or in the water. You can see fresh bubbles coming out of the sand if you're underwater, if there's summary groundwater discharge. Or even in the sand, it kind of creates these little pools that wash into the salt water.
How do you process the samples?
You rinse every single sample, and you do every single sample 3 times. It's a triplicate rinse. 3 is our favorite number. You're basically trying to pull off anything that's not the algae that you actually want. A lot of algae are epiphytes. You have turf algae that grow on other macroalgae, so you have to rip all those off. You get a lot of sand that clumps in certain species, so like ova, a lot of sand gets in all the blades. You need to get all of that out. You pat it with a towel 3 times. You make like a dumpling, little Limu dumpling, and you shake it 10 times, and then you put it in your foil packet, and you do that for every single sample. And then you take your entire pan and you put that in the oven, and it sits in the oven at a pretty low temperature for a few days, normally like 3 or 4, and you grind every single sample with a mortar and pestle, and you dump that into your little vial, and you do that for every single sample. And then they have their own schedule at the isotope lab at SOAS to post at UH Manoa, who we did all of our work with. So I'm really hoping that our data comes back and we can do something about it so that it benefits everybody that's on the island. The water's kind of our life source here. The water here is for everybody. Without healthy reefs, we don't have happy people.
We are looking for a few heroes, mentors, trailblazers, innovators, a passion to change lives, spark curiosity, open hearts, and awaken minds, help students answer the question, who am I? This could be your calling, but this is no job. It's the journey of a lifetime. Be a hero. Be a teacher.
Welcome back to Voice of the Sea. We're talking new technologies with Stuart Coleman from Wastewater Alternatives and Innovations.
we started realizing that that background pollution that we thought might just be runoff during storms in certain areas was chronic, and started figuring out that this was most likely from cesspools, because we're talking about 53 million gallons a day are being, discharged, more than 88,000 cesspools across the state. Right now, Hawaii is last in the country. We were the last state to ban the creation of new cesspools at a minimum of $20,000 to upgrade those. We're talking about a $2 billion problem. And so it's one of the biggest problems the state is facing. We need to have more inspectors and more people that can pump these systems and maintain them. With the COVID crisis, it's difficult because funding is going to be tight, but then also we're being asked to submit proposals for work development and workforce development to get people back working and in jobs. And this is one of the biggest problems in the state, so it might be a good thing to do. It's not just a problem for people who have cesspools or failing septic system. It's all our problem because it's degrading the reefs, the nearshore ecosystems. 48 million gallons was the worst sewage spill we've ever had in 2006. But every day we're releasing 53 million gallons into our groundwater and surface waters. It's just beneath the surface, and so no one really knows about it until they see the degraded reefs or the poor water quality, or they get a staph infection or a waterborne illness like gastroenteritis or something. Look into what kind of system you have. When was it last maintained? Can it be upgraded? And what we've really gotten excited about is trying to find technology that recycling the waste. So you separate solids and liquids, you burn the solids so they're 100% pathogen-free, odorless, and often without all the harmful chemicals, and then you produce biochar and recycled water. So in the process, the waste becomes the fuel that helps it burn, and then you use that heat to pasteurize the water, and so you get this output of recycled water and biochar. On the single-family home, there are single-use toilets, incineration toilets. And I know that's not two things you want to hear together, incineration toilets, but you don't need any plumbing connection. And it just incinerates everything that you put in it. And, for a family for typical use, you just have to take out the ashes once a week from a small drawer, and you can dump them in your garden. And it's NSF approved, which is the standard the DOH uses. So that's the household level. And then there are ones that you can use for parks and schools and communities that are multi-use reinvented toilets. Those fit in a 20 or a 40-foot shipping container and have maybe 4 to 6 stalls, and it does the same thing. And either recycles the water for the flushing or has a small water output. We're working with a group called Ridge to Reefs that does bioreactor gardens, and they use biochar and sand and filtration and then vetiver grass. You take that effluent that comes out of a holding tank or a septic tank, the nutrients are taken up by the roots of these plants, filtered also through the biochar. It's sealed at the bottom so nothing can get through to the land. And then you have a beautiful garden that has no odors and is taking care of all your waste. And there's zero discharge. So we're already working on a number of grants to bring the technology to Hawaii, finding local partners, setting up pilot projects. And even though the COVID crisis has set back our timeline, we still hope to have these on the ground by the end of the year.
Next, we talk to Michael Mezzacapo from the Water Resources Research Center.
It's my job to connect our researchers at the university to community members, stakeholders, policymakers, so that they have the best science available to make important decisions about water resources. Back in 2016, we passed Act 125, which mandated the conversion of all cesspools by 2050. The state has about 88,000 plus cesspools. We have unique geology, we have unique hydrology, and so it's important for us to start with a homegrown plan here. Each of the islands is different. Big Island has the most cesspools with over 50,000. And it's the most rural, and it's a place that you couldn't put a lot of municipal sewers. And even on Oahu, there are parts of the North Shore that are very rural and difficult to get to. It's looking at what are the technical solutions, what are the financial solutions to help people, because this is often, it's scary because it is a big investment, but it's an investment in the environment and the things that we use every day. We're not going to point fingers. Let's go and figure out how we can really raise everyone up together and get them to convert their cesspools. So there's ongoing research that the state has commissioned. We're looking at what kind of grants or loans we can give to people to help them upgrade their systems without having to shell out a bunch of money at first. And then what are the technical solutions? So what are the new types of systems that we can use? There are on-site systems that can reduce the amount of nitrogen by a lot. The average cesspool might input more than 60 milligrams per liter of nitrogen. We have new advanced systems called ATUs, or aerobic treatment units, and they can output as little as 10 milligrams per liter of nitrogen. Aerobic treatment units, similar to a septic tank, but they use aerobic and anaerobic bacteria. So it's almost like a little mini municipal wastewater treatment system at your home. They'll use fans and blowers to incorporate air into a second chamber that further degrades the solids and waste. And then it heads out a similar engineered drain field or leach field, or a more advanced one, a biofiltration unit, or you can accompany those with engineered wetlands so that you can send that wastewater into a wetland and it'll further take up all the nitrogen and different things within the wastewater. New technologies like that, or composting toilets for very rural areas, that we may be able to get the state to test and approve, and then people can input those in their homes so it's not as much money. In Hawaii, we've already told people that we want them to convert by 2050, but we haven't really come up with when they would have to convert. We're looking at that prioritization. That's a separate report to figure out what areas are most impacted, and then reach out to the communities and talk to them about barriers that might be unique for each community, and then really work together with creating that prioritization plan to say, this area has the most impact, so we'll help you upgrade.
How did you get interested in cesspools and water quality, its effects on human health?
Oh, sure. I used to work in healthcare, and human health has always been an important. It was something that I was interested in. I was deeply connected to the environment. I grew up with my grandpa farming, and so we did a lot of things like composting and made sure that, whatever we put on the land was going to be safe because we were eating from that land. I didn't specifically seek out to work on cesspools, but this amazing opportunity had come up, and the work that I'm doing is going to be contributing to a better environment for us as humans, but also for the wildlife and the fish and the other creatures that inhabit the environment. We rely on the environment. It's important to have healthy air and clean water. If we're not taking care of that, then we're not taking care of ourselves.
Cesspools are leaching wastewater into our environment, contaminating our water systems and negatively affecting the growth of algae and coral reefs. Hawaii has less than 30 years to replace over 80,000 cesspools. Learn more at voiceofthesea.org. Follow us on social media at Voice of the Sea TV. Mahalo for watching Voice of the Sea. Exploring Our Fluid Earth is the dynamic curriculum developed by the University of Hawaii's Curriculum Research and Development Group. The award-winning Fluid Earth and Living Ocean textbooks are now interactive and online. New activities, updated content, and a teacher community. Exploring Our Fluid Earth is now freely available. Find out more at exploringourfluidearth.org.